By the end of this video, you will understand the different regimes in which wave scattering take place. Wave scattering is a phenomenon we experience on a daily basis. For example, when we receive a cell phone signal in the interior of a building, or when we are able to hear a conversation from behind an obstacle, or when we see water ripples bend around a stone. This so-called bending of a wave depends primarily on the relative size of the obstacle to wavelength. Finite difference time domain (FDTD) is a numerical analysis technique used for modeling computational electrodynamics. This is a widely used technique in which space is divided into a discrete grid and then the fields are evolved in time using discrete time steps. And one can simulate many practical problems essentially exactly. For example, this is the simulation of a parabolic reflector antenna in the transmitting phase. And this is the simulation of total internal reflection occurring inside a glass prism. Glass prism can be used to bend the light by 90 or 180 degrees. Now, let's move on to see the simulation of wave encountering a very small object placed in front of a point source. The blue color represents the positive maximum and yellow color represent the negative maximum. The size of the object is 1/4 of the wavelength and it can be concluded that the wave is almost undisturbed by the presence of very small obstacle compared to the wavelength. Now, consider the second case in which the size of the object is increased. The size of the obstacle is equal to the wavelength. Here, you can see the interference pattern formed by the incident, reflected and the transmitted wave. The wave bent around the corner and some intensity of it can be seen in the immediate right side of the obstacle. So we can conclude that when the size of the object is in order of the wavelength, diffraction becomes more evident. Now, consider the third case in which size of obstacle is 7 times the wavelength. It effectively shadows the wave. No intensity of the wave is observed in the right side of the obstacle. This is the table for all the design parameter used in the simulation. And this is the meat code for its implementation. Hope you enjoyed the video. Thank you.